Exercise 6.2 of class 10, name of the chapter, Triangles. So, I'm going to start in this lecture. This is the second part, name of the chapter, Triangles of class 10 CBSE board, exercise number 6.2. I'm going to start with you in just a while. I'm going to share my screen along with you. Now, this is the question. Exercise is 6.2. I'm going to start with question number 2 because question number 1 I'm explained that question in the previous video. Now the question number 2 we have of the exercise 6.2, name of the chapter, Triangles of class 10th CBSE board. Now question number 2, E and F are the points on the sides PQ and PR. You can see over here in this question, E and F are the points. Question number 2 I have explained to you in the previous video. Now question number 3. In figure 6.18, that means for this question number 3, this is the figure. LM is parallel to CB. This LM is parallel to CB and LN is parallel to CD. Now we have to prove that AM upon AB is equal to AN upon AD. Now I'm going to start how to solve this question. The question is here. So, if we saw this question from here, in triangle AML and ABC, now it is given that LM is parallel to CB. So from the basic proportionality theorem, we have ratio of AM to ratio of MB. It is equal to ratio of AL with ratio of LC. This is the basic proportionality theorem. If the two lines are parallel, then ratio of their sides is equal. Basic proportionality theorem. That means what is the theorem mainly? That means, for example, there is a triangle, and if these two lines are parallel to each other, then ratio of this side and ratio of this side, that means if it is A and it is B and it is C, it is D, then A by B is equal to C by D, if these two lines are parallel. Now in the same way in the question it is given to us LM is parallel to CB, that is LM is parallel to CB, then ratio of its side, ratio of this triangle AM and ratio is MB, which is equal to AL and LC. Now similarly, in triangle ALN and triangle ACD, it is given as LN is parallel to CD. So AL over LC is equal to AN over ND. Now this is the equation number 1 and this is the equation number 2. Now comparing both of them, we can see over here, this is AL upon LC and this is also AL upon LC. So this is get cancelled and we left with AM upon MB, which is equal to AN upon ND. And this is the required ratio which we have to prove in this question. So we write over here proved. Now this question is completed. Now I'm going to shift to the next question. Now next question in the exercise, we have question number 4. Now this is the diagram and here we have to prove this. You can see over here in figure 6.19, DE is parallel to AC. This DE is parallel to AC and DF is parallel to AE. We have to prove this equation. Now I'm going to solve this question. Just see how will we solve this. Okay. Now this is the question we have. Here it is A. Now see over here. Firstly consider this figure. A, B and C. DE is parallel to AC. This is DE. It's parallel to AC. Now, it is given that DE is parallel to AC. So, if two lines are parallel to each other, then ratio of their corresponding sides are equal. So, BD upon AD is equal to BE upon EC. And reason is basic proportionality theorem. Now, DF is parallel to AE. Now, this is the triangle. Now, we just only draw AE. Okay, that is DF is parallel to AE. So, here it is given DF is parallel to AE. So, we take two sides BD over AD, and for AE we have BF over FE. So now comparing equation number 1 with equation number 2, we can see BD over AD is there and also BD over AD is there. So comparing both of them, we get BE over EC, which is equal to BF over FE. BF over FE, BE over EC. So that is proved. Now the next question of this exercise. Question number 5. And figure 6.20. Now this is the figure which we have to look for this question. Question number 5. Now I bring this figure to a screen and then I'm going to explain you. Now in figure 6.20, DE is parallel to OQ. DE, this line, is parallel to OQ. Now from here you can consider like this. This is the triangle. Let this is DE. And this is P. And this is Q. This is O. Now it is given DE is parallel to OQ. So it is given DE is parallel to OQ. So now the ratios are equal. PE upon EQ is equal to PD upon DO. Reason is basic proportionality theorem. Now similarly, it is given DF is equal to OR. You can see DF is this and OR is this. So now we can make the triangle like this. P, this is D, this is F, this is O, this is R. So it is given DF is parallel to OR. So PD upon DO, which is equal to PF upon FR. Now we compare both of them, equation number 1 and equation number 2. We can see that PD upon DO is there and also PD upon DO is there. So ultimately from 1 and 2, PD upon DO get cancelled and we get PE upon EQ, which is equal to PF upon FR. Now we observe where this ratio goes. PE. So PE we can see this. Then EQ, then this. Then PF, this is this. And FR, that means this. That means the whole of the triangle, that is the big triangle. So in the big triangle we can see this line EF and this line QR. Okay, if we make the triangle like this, it becomes like this. P, E, F, Q, R. Now if we join them, it becomes PE, EQ, PF, FR. So here EF is parallel to QR. So EF is parallel to QR. And this is, it is asked in the question. Now hence proved. Finish. So after this line, you have to write this. Now next question, question number 6. We have a figure also. So I have shifted to the exercise. Question number 6. This is the figure. Okay. This is Q. Now in figure 6.21, A, B, C are the points. These are the points on OP. This is OP, OQ and OR. Now AB is parallel to PQ. AB is parallel to PQ. That means if we consider the diagram for AB is parallel to PQ, the diagram goes like this. This line AB is parallel to PQ. This is PQ. These two lines are parallel. So when these two lines are parallel, then their ratios are equal. So we can write, this is O. OA upon AP, which is equal to OB upon OQ from the basic proportionality theorem. Lines are parallel, then ratio of the sides are equal from the basic proportionality theorem. Now, second, AC is parallel to PR. You can see AC is there and this is PR. Now you can understand the figure goes like this. Similarly, O is the center. This is P, this is Q, this is R, this is O, this is AC. Clear? Now it is given to us AC is parallel to PR in the question. AC is parallel to PR. So we can write OA upon AP is equal to OC upon CR. That means this ratio is equal to this ratio equal to this. Now if we compare 1 and 2, we can see that OA and AP is there, OA and AP is there. So from 1 and 2, OB upon OQ, which is equal to OC upon CR. Now show that BC is parallel to QR. We have to show BC is parallel to QR. Now we have the quotation OBOQ. We can see over here. This is OB. This is OQ. The whole OQ is given to us. Now if we see this diagram, this is OB and OQ, whole OQ is given to us. Now OC and CR, this is OC and this is CR. We have not to write OQ. OB upon BQ we have to write. Sorry. So here we have BQ. So it is obvious these two ratios are equal. So in the last we simply write BC is parallel to QR. That means what is the summary? Summary is that, for example, we have X, Y, Z. Let it be A and B. Then if AB is parallel to YZ, AB is parallel to YZ, then ratio of AX to ratio of AY, ratio of BX, ratio of BZ. This is equal. So this is the theorem. Now question number 7 of your exercise. Actually this is the summary which I am explaining to you. Now question number 7. Now this is the theorem which we have to prove in question number 7. 7th and 8th both are theorems which we have to prove. Now I am writing that theorem for you. And actually these two theorems are very important. Question number 7. Prove that a line drawn from the midpoint of one side of the triangle parallel to another side bisects the third angle. Now here we have to draw the triangle. Let it be A, B, C, and midpoints are P and Q. So here PQ is line segment drawn through the midpoint. Such that PQ is parallel to BC. Now, AQ upon QC equal to AP upon PB by the basic proportionality theorem. So we know that AQ over QC is equal to 1:1. Why? Because Q is midpoint of side AC. It is given in the question. You can say midpoint of one side of triangle. This means Q and P, these are the midpoints of these sides. So AQ over QC is equal to AP over PB, which is equal to 1:1. So AQ is equal to QC. Now the next question. This is also the theorem. Prove that the line joining the midpoints is parallel to the third side. Now it is given that in this triangle ABC, and let it be PQ. It is given that P and Q are midpoints. It is given that UQ is line segment joining midpoint of line AB and AC. So AP is equal to PB because it is a midpoint, and AQ is equal to QC because that was a midpoint. So when we find the ratio AP, we take PB over here, PB which is equal to 1. Similarly, AQ over QC which is equal to 1. Now both are equal to 1. So we can write AP upon PB is equal to AQ upon QC is equal to 1. Or you can say these are equal. So when the ratios are equal, then we can say that PQ is parallel to BC. So it is proved. So these are the two theorems. If the theorem is asked in your examination, you have to write this. Now the next question of the exercise, I am going to explain you. Now in this question, figure is not given to us. We have to draw the figure. APCD is a trapezium. So APCD is a trapezium, so we can write like this. It has 4 sides. AB is parallel to CD. That means these two are parallel to each other. Diagonals intersect at the point O. If we draw the two diagonals of this trapezium, they intersect at O. Show that AO, this AO upon BO is equal to DO upon CO. We have to prove this. Now, how to prove this? We just draw a line like this. Let it be EF. Now, we just write a line, draw a line EF through point O such that EF is parallel to CD. We draw in such a way that this EF line is parallel to CD. Now in triangle ADC, you can see like this. If this is a trapezium, this is A, this is B, this is C and D. And for example, this is a diagonal. So we can see this is O and this is E. I have taken the half of the trapezium. So from here, if EO is parallel to CD, then AE upon ED is equal to AO upon OC, equation number 1. Now similarly, in triangle, which triangle I will take? ABD. That means we take the triangle in the reverse form. That is A, B and D. This is the diagonal. This is the line E and O. And we take EO is parallel to AB. EO is parallel to AB. Then from here we get AE upon ED. That means this upon this. Similarly, BO upon OD. Equation number 2. Now comparing 1 and 2, AE and ED both are same, so we can cut. So it becomes AO upon OC, which is equal to BO upon OD. And this is the in the question we have to prove. So it is proved. Now last question of this exercise, question number 10th. You can buy the recorded lectures of class 10 by contacting our phone number for future revisions. Now the last question. The diagonals of the quadrilateral ABCD. Now quadrilateral is of the same shape A, B, C and D. Intersect each other at the point O. The diagonals intersect each other at the point O. We have to prove AO upon BO and CO upon OD. Now in the same way we can do this question. We just draw a line parallel over here clearly. And the same way DE, let it be E, let it be O. OE is parallel to AB. So DE upon EA, which is equal to OD upon OB, with the help of basic proportionality theorem. Now similarly, I will take this in triangle ABD, because we take OE and AB. OE and AB. Now in triangle ACD, EO is parallel to CD. Now we take this line and this line. So from here AE upon ED, which is equal to AO upon OC. Now comparing 1 and 2, these two comparing, AE and ED, they are the same. So we write OD upon OB, which is equal to AO upon OC. So we have to prove AO upon BO and CO upon DO. So we just cross multiply and write in this way: OC upon OD, which is equal to AO upon BO. Proved.